Welcome to the Night Club. We're going to go over Chapter 4 today in Advanced Math Plus.
Arr, Mitchie.
Yes. All right. Number 1. It said to find all the zeros of 10x to the 4th minus 19x to the 3rd minus 4x squared plus 19x minus 6. All right. If you remember, this was like one of the last two on your mid-test. Okay. You're going to plug it where first? Y equals, and graph it. And again, when you do this, your calculator is going to give you all 4 answers, but you're only going to use 2 of them. Okay. So I go to y equals, I plug it in, 10x to the 4th minus 19x to the 3rd. My watch is talking to me. Minus 4x squared plus 19x and minus 6. And we hit graph. Oh, I still got my plot on. Let me cut. You go if you have dots, go to your y equals and go to your plot 1 and cut it off. Okay.
Wait.
Just unhighlight it.
Unhighlight plot 1?
Unhighlight plot 1 and it should take the dots off.
Oh, I cleared it.
Trace.
Whoa, how do you do that again? How do you unhighlight it?
Hit enter.
And then you go to graph.
How do you get the dots?
And you graph it. Yeah. All right. So there they are.
Why are we doing an error here?
I don't know what we're talking.
All right. So once you have it graphed, again to get the regular window that you want, Zoom 6 does that. I can look and tell. All right. It looks like it's going through -1 and 1. Those are the 2 I'm going to try. The other 2 could be probably fractions, but I know 1 and -1 should work. So I'm going to do my synthetic division. It does not matter which one you do first. I'm going to do the -1 first. Bring down my coefficients. That would be 10, -19, -4, 19, and -6. And remember, if you skip a term, okay, if you skip an x to some power, if you skip a number, you have to put 0, okay? So we didn't skip any here. It went 4, 3, 2, 1, 0. So no zeros. Bring our first 10 down. Multiply -1 times 10, you get -10. Get -29 when you add those 2 numbers up. Times -1 will be +29. -4 and 29 make 25. Multiply that times -1, we get -25. 19 and -25 make -6. -1 times -6 is +6. And we get a remainder of 0, which is what we wanted to get. If you don't get a remainder of 0 here, something is wrong, because you should get a 0. So I do it again with my other 0 that I know, which was 1. Again, does not matter if you would have picked the 1 first. You could have done that. That's fine. Bring down my 10 again. Get 10, -29. It'd be -19 times 1 is -19. Add those up, you get +6. 1 times 6 is 6, and we get 0 for our remainder again, just like we should. So now I have 10x squared minus 19x plus 6. And we do our quadratic formula. I'm going to write it out for you. You need to have it memorized. After you leave this class, your next math class in college or in high school or wherever it may be, it will be in there, the quadratic formula. Just one of those things you got to learn. What is B? -19 plus the square root of negative 19 squared minus 4 times A. A is 10 and C is 6. All over 2 times A again is 10. So you can stick all that in your calculator if you want to, because pretty sure we're getting a nice rational answer, okay? You just have to do it twice. So I'm going to go to, I got to go back anyway. So alpha x, we'll pull it up, or alpha y equals, also do number 1 there. And basically we're just plugging in. So let me go back to what we were plugging in here. We got, all right, negative a negative 19. Negative 19. I'm going to do plus first. The square root of negative 19 squared minus 4 times, what was A? 10? And then times C was 6, correct? So all over 2 times 10. All right. And you hit enter. There's one answer. I think it was positive 6. Yeah. Yeah. All right. And then I do the exact same thing, but this time I do what? There. Put a minus. So I'm going to hit second enter. Brings it all back up real quick. And then scroll up and change that plus sign to a minus sign. Real important that you put a minus sign there, not a negative. Okay? If you do negative, it'll think you're multiplying. All right? So make sure you use the actual minus sign. And there's my other 0, 2/5. So my final answers are x equals 1, negative 1, 2/5, and what was the 3/2? There's all 4 of my answers. Okay? Like I said, exact same as the last 2 problems on the mid-test that I just handed back. So, need some extra. 2 and 3 were also from the mid-test. They are asking, determine which consecutive integers do not have a real 0 of the function. So here's the function. F of x equals x to the 3rd plus 5x squared minus x minus 6. And you're just figuring out which one is not between. So like for part A, it's 2 and negative 1. Is that right?
Negative 2, negative 1.
Negative 2, negative 1. B is negative 5, negative 4. C, 1, 2. And D, 2, 3. And I apologize, I said this was from the mid-test, but this was not from the mid-test. This is just, this was your first lesson in this next section, so 4, 5. But all you're doing is graphing it and seeing which one does it not come in between. Okay? So go to y equals and plug that into your calculator. Y equals x to the 3rd
Plus 5x squared.
Plus 5x squared.
Minus x minus 6.
What in the world? Hold on, something's wrong here. How did I scroll down? Oh, I guess I hit the arrow, I guess. Plus 5x squared. What'd you say was after that?
Minus x minus 6.
Minus x minus 6. All right. So let's see here. Right here, 1, 2, 3, 4, 5. Looks like it's in between negative 4 and negative 5. This one here is between negative 1 and negative 2. And this one here is between 1 and 2. So which one is it not between? 2 and 3. So D. Okay, that's all there is to those. 3 is the same way. I gave you 2 of these. So nice. f of x equals x to the third plus 5x squared again. This time it's minus 2x minus 23. And A says 1 and 2, B says negative 6 and negative 5. C is negative 3, negative 2. And D is negative 5, negative 4. So, plug that in, y equals. So this one is minus 2x minus 23. And I hit graph. Which one does it not go in between?
It goes between 1 and 2.
One and two, negative 3.
It's negative 6, negative 5.
It is negative 6, negative 5. It does not go between negative 6 and negative 5. So that is my answer. B. Okay? Any questions on how to do that? Pretty simple. Four and 5 are also just calculator problems. It says to approximate to the nearest tenth the real zeros of the function. So there's no work to show. You're just making sure, you're just showing me that you know how to use your calculator the right way to find the zeros. So, again, we're going to plug them in. 5x to the third minus 14x squared minus 13x minus 2. And I'm going to graph that. Plug it in my calculator. 14x to the third. Oops, that's wrong. 5x to the third. Minus 14x squared. Minus 13x.
Minus 2.
Minus 2.
You need a minus sign in between.
I sure do. Thank you. That would not have worked very good, would it? Alright. Graph. So, understand what you're doing here. You're not figuring out what they come in between. You're figuring out what is the actual answers. So, where do I go on my calculator? Do y'all remember? Second, trace, and I'm trying to find the what? The zeros. Number 2. So I go left, I'm going to go from left to right. You have to do this 3 separate times. 1, 2, 3, 0. So I got to do it 1, 2, 3 times. Okay? So I go left of my 0, hit enter, make the cursor to the right, which puts it above it. Don't go so far that you pass the other 0. Okay? I can't go down here. Even though it is to the right, it's also to the right of both zeros. I can only be to the right of one of the zeros. Okay? So anywhere up there would work. Enter, and press enter one more time. So 1, 0. The directions did say to round to the nearest tenth. So that would be negative 0 point what? Negative 0.6. That's one answer. Then I'd go through the whole process again. Second trace. I want to find the 0 again. This time I'm doing the middle 0 right here. So I'm going to go to the left of it, which means above it, basically. Enter. Then scroll to the right till I'm below it. Enter, enter. That one I don't have to round. It's already rounded for me. Negative 0.2. And then last but not least, the one on the right. All the way over here looks like it's 3 point something. So second trace, number 2. Scroll to the left, even though I'm going right. There it was, sorry. Enter, scroll to the right, enter, enter. 3.6. So my answers are, what were they again? X equals 0.6, 0.2.
Negative both of them.
Thank you. Those were both negatives. My bad. negative 0.6, negative 0.2, and positive 3.6. Is that right? That's all there is to those.
It was negative 0.7. I'm kidding. I was trying to mess you up.
5, you're doing the same exact thing, just with a different equation. So two calculator problem, basically 4 right here in a row. Plug it in. Let's see here, that's going to be a 2 plus 9x squared minus 2x minus 3. Hit graph. Again, I got 3 zeros, 1 there, 1, 2, and 3. So going from left to right, I'm just going to do the first one, the one on the left first. Second trace, number 2. Move my cursor to the left of it. Oop, there it was. Enter. Scroll to the right. Enter and enter. Negative 4.6. 1, 0, negative 4.6. Do it all over again. Do the middle 0 this time. Make sure it's just to the left of it. Go just to the right of it. Enter, enter. Negative 0.5. And last but not least, the last one. Enter. And enter, enter. 0.6. So, we have x equals negative 4.6, right? And then negative 0.5, and then x equals positive 0.6. Okay? Any questions on how to use your calculator to get those? Everybody good? Awesome. 6, 7, and 8. I tried to give you the easiest rational equations I could.
You can do that on the test?
It'll look very similar to the one on the test, yes.
Will it be the same?
It will be different numbers,
Will it be the same?
probably different letters, but yeah, I mean, it's the same
Can you use like
thing.
an L or something?
I'm sorry?
Like an L? I prefer that one.
An L? No,
Just for luck.
just for luck.
On the test.
Maybe next time. I'm sorry.
Christine.
You're supposed to multiply everything by the common denominator, right? But when they're written like this, these are, what are these called? Starts with a P? Ends with a or portion?
Portion.
Proportion, okay? So,
We're really quick on it.
yeah, that's I was helping you as much as I could there. All right, so right here, when it's a proportion, what have you always done?
Cross multiply.
And set them
Equal
equal to each other. That's all you do here, okay?
Cross multiply is that.
Cross multiply, set them equal to, so this is going to be negative 3m times m plus 3 equals negative 3m minus 1 times m minus 5. And you work it out. Okay? Distribute.
You wrote that
Distribute the left side.
C4 just coke again.
Negative 3m times m is what?
Signature cassette came back on.
Negative 3m squared.
Negative 3m squared. Negative 3m times positive 3 would be negative 9m equals negative 3m times m again is negative 3m squared. Negative 3m times negative 5 is positive 15m. Negative 1 times m is negative m. And negative 1 times negative 5 is positive 5.
Okay.
What do you notice about the negative 3m squareds?
They're gonna cancel.
They will cancel each other out, which is a good thing, because that means no more quadratic, right? Linears are good. So,
You got a
15m 15m minus m is what? God bless you. 14m plus 5, and then move my 14m over to get my m's on the same side. That's negative 23m. Is that right?
Yes.
And then divide by negative 23. Not negative 25.
Why is always the ugliest numbers?
So my answer is m equals negative 5/23.
I need you to like step away from the wall.
Rule 6.
Like hot moms.
All right, number 7. Same process. This time they went with the Q.
Cute beans, bro.
Q's not an L. Sorry, Kenzie.
I heard you, Ricky.
You wanted an L. It's a Q. Q doesn't get enough love though. They're not.
Yeah, but you can't take
They're not ugly.
you can't take you away from Q because they're always married.
You would be.
It's true.
It's kind of sad.
They kind of go together. All right, same process. We're just going to cross multiply. Negative 5q times q minus 3 equals negative 5q minus 6 times q minus 5.
Wait, can we always cross multiply?
When they are proportions,
How
yes.
do you have to?
If you had something like this on the end, by proportion. Okay? Bye.
You maybe forgot about it. That's okay.
I don't think I did.
No, he didn't.
There's two different parts.
Not in the part I was singing. What in the world is happening here? I hit the wrong button.
Yeah, you did.
See, now you get confused.
Alright,
The Q's look like nines.
Maybe you just ride them like
No,
that.
you write them
How do
like
you write
that.
them like that?
Q's look like 9s?
Nine.
Because you just draw like a.
Do you leave the tail off?
How do you draw that?
There's
I
no
just tried
tail.
it.
How do you draw the tail?
We'll look at the tail.
I know.
That was like a G. She kind of did like a 6.
What did you say?
I wish I could show you.
Alright, distribute. Negative 5q squared plus 15q equals negative 5q squared again plus 25q minus 6q plus 30. The negative 5q's do what once again? They cancel out. What's 25q minus 6q?
19.
19q. So I'm going to subtract 19q from both sides. And that will be, that looks like plus 19q. I'm going to change that real quick. Minus 19q. That'd be negative 4q equals 30. Divide by negative 4. Never, ever leave your fraction unsimplified. So what would that simplify to? Negative 15 over 2. If you put negative 7.5, I would accept it, but
Keep it a fraction.
all the rest I were fractions.
Because I got it on me.
All right. Any questions on number 7?
Hold on. No, I'm good actually.
Everybody good? All right. All right. Number 8. I know it says P's, but in honor of Kenzie, we're going to go with the L. L minus 2 over L equals L minus 4 over L plus 4.
L cells kind of weird.
Okay? They don't use L's a lot because they like using lowercase letters, and a lowercase L looks like a 1.
Unless
You
put a
could.
cursive one.
And you can do a cursive one. You're right, but I'm just saying. That's why your book doesn't use lots of spells. Alright, so cross multiply one more again. L times L minus 4 equals L plus 4 times L minus 2. Distribute. L squared minus 4L. Not 4L, but 4L. Because I'm happy, okay?
This looks like 1 squared. and
L
it's
times
bigger than
L is L squared. L times negative 2 is negative 2L. 4 times L is 4L. And 4 times negative 2 is negative 8. It was
that.
Kenzie's
The world
idea.
can only-
So, what happens to my L squareds?
They go away.
They go. They take the L and get out of there. Thank you. Negative 4L will now equal 2L minus 8, and I subtract 2L over. So negative 6L equals negative 8. Divide by negative 6. L equals 4 over 3.
I'm gonna just put that.
And like I said, it is P on your sheet, so P.
So negative 4L. Negative 6L.
Alright, everybody good? Wonderful. Number 9. We are decomposing
so smooth.
fractions here. Some of you may have forgotten how to do this,
Did not do it.
or never learned it in the first place. So,
The second one.
there is a good thing about these 3 problems. They've done part of the work for you. Okay, they wrote the denominator as factors. Okay, so you know what your fractions are going to be over. I'm going to have 2 fractions. One of their denominators will be what? X minus 4. The other one will be x plus 2. So that I know that. God bless you. That's a good one. X minus 4, x plus 2. Now we just have to find the numerators. What do we let be the numerators for now?
Oh.
A and B. Do you have to do A and B? No, you can do whatever you want to. Okay? I'm just going to do A and B. All right? Now, solve that rational equation. We need to multiply everything by the common denominator. What is the common denominator on this one? X minus 4 times x plus 2. So I'm going to multiply the top. X minus 4 times x plus 2 for everything.
Wait, why did you do that again?
To get rid of the denominators. Okay? We're trying to make this fraction equation into a regular equation without fractions.
Pause that for a second.
All right?
Stop the video.
So now we've got them all multiplied, we can cancel some things. So here, the x minus 4's cancel, and the x plus 2's cancel, and I'm left with negative 3x. Equals. Here, the x minus 4's cancel. So I'm left with a times x plus 2, plus, on the b, the x plus 2's cancel, so I'm left with b times x minus 4. And at this point is where we do our 2 equations. Because again, we have 2 variables, we have 3 variables, but we have 2 variables that we're trying to find, A and B. In order to do those, we need to get rid of one of them. Okay? So I'm going to get rid of the B first, just because it's B. Alright? What do I plug in for x to get rid of the B? 4. 4 minus 4 was what? 0, and 0 times B would be 0, and the B's gone. Bye-bye. So for this one, I'm going to let x be 4. So negative 3 times 4 equals a times 4 plus 2. Again, I'm not worrying about plugging it into the b part because it goes away. That will be negative 12 equals 6a. Divide by 6. So a is negative 2. Okay? So, to get rid of the a, what am I going to let x be? Negative 2. So for the second one, I'm going to let x be negative 2. That'll cancel out the a, so negative 3 times negative 2 equals b times negative 2 minus 4. That's 6 equals negative 6 times b. Divide by negative 6 and we get negative 1 is b. And then for my final answer, I take my numerators that I found and put them over the denominators at the beginning. So x minus 4, a was over x minus, so it's negative 2 over x minus 4, plus, what was b? Negative 1 over x plus 2. There are your partial fractions. Okay? And again, understand what the problem is asking you to do. It's you're taking this big fraction that's just one fraction and breaking it into the two parts that you added together to make it. All right, we got two more like this. Number 10. There we go. 10 says 5x over x plus 1 times x minus 6. And again, they're doing us a huge favor by already factoring it for us. So I know one denominator is x plus 1 and one is x minus 6.
On the test, will they all already be factored?
Yes. Just like you can do the review, you can do the test. Okay?
This is the exact same thing.
It's not the exact same thing, no, but it's fairly close. How many times have you had me now? You know how they are. The test and the reviews, they're the same. I mean, they're not the same, but yeah, they are the
You
same.
work this problem just like the last one.
Just like the last one. So I'm going to multiply everything by the common denominator, which is?
X plus 1, x minus 6.
Very good. Same process for all three of them. I hope not. The denominator's on the left, the whole thing goes away because they all cancel, and I'm left with 5x equals, on the right, the x plus 1 goes away, I'm left with a times x minus 6 plus b times the x minus 6's cancel, so you're left with x plus 1. And you make your two equations. So to get rid of b, I'm going to let x be what? Negative 1. Plug it in. 5 times negative 1 equals a times negative 1 minus 6. Negative 5 equals negative 7a. So a is 5/7. So don't let that scare you. It's okay if it's a fraction. All right?
So every
It
time,
ain't pretty, but it's okay. Yes, sir.
every time you look for B first, you just do the opposite of that.
You don't have to look for B first. Or you don't have to get rid of B first. I just do it because I like getting A. I like them getting in order. It doesn't matter though.
You
Yes,
just
ma'am.
always choose the opposite of that one.
Whatever makes that part 0. Yes.
So the x, how did you get the x again? The x equals.
It made. I'm trying to figure out what makes that be 0.
Even though you're finding a.
Correct.
Okay.
To find A, I got to get rid of B. And to get rid of B, I need it to be multiplied by 0. Because B times 0 is 0.
Be 6.
Okay? Right. My next one, I'm going to try to get rid of A. So what would make this 0? 6. So the second one, I'm going to let x be 6. Okay? 5 times 6 equals B times 6 plus 1. So that's 30 equals 7B. So B is 30 over 7.
Pause up.
Mm-hmm.
Which one is it?
All right, so we take our denominators, or our numerator, excuse me, and we rewrite our fraction. So 5/7 over x plus 1 plus 30 over 7 over x minus 6. Now, you can write it like that. I believe that's how they have it written on the answers. If you want to get really fancy, this is also acceptable. Ugh, that's ugly. You just put the 7 in the denominator with its buddy down there, okay? But like I said, that one's perfectly fine. Write it that way so you don't make any mistakes, okay? It is quite ugly though. I'll agree.
I just didn't think that was right.
It's right. All right.
Like they always say that you can't do that. That's not right.
11. One more of these.
We don't have to do that if we're running out of time.
We got negative 2x over x minus 6 times x plus 5. So again, we know our denominators. We just write them down. Put a and b as our numerators. And we multiply everything again by the common denominator, which is x minus 6 times x plus 5. Okay? The x minus 6's go away, the x plus 5's go away. I'm left with negative 2x on the left side of the equals. On the right side, the x minus 6's cancel. A times x plus 5 plus the x plus 5's cancel. B times x minus 6. Make our two equations. To get rid of b, what are we going to let x be? 6. So that would be negative 2 times 6 equals a times 6 plus 5. Another ugly fraction. But ugly fractions are numbers too. So a is negative 12 over 11. What do we let x be to get rid of a? Negative 5. That would make 0. So negative 2 times negative 5 equals b times negative 5 minus 6. So we get 10 equals negative 11b. So negative 10 elevenths is b, and negative 12 elevenths is a. Negative 12 elevenths over x minus 6 plus negative 10 elevenths over x plus 5. Make sure when you write them that you don't get them mixed up and put a over the wrong thing and b over the wrong thing, okay? So yeah, always go back to the original. All right? All right. 13 and or 12, 13 and 14 and 15 and 16 are more equations. 12, 13, 14 and 15 are all radical equations, so we're going to have a radical in there with it. 12 says to solve the square root of x minus 13 minus the square root of x equals negative 1. Now, what can we do to make this problem a little easier? Move the square root of x over, okay? It's just going to make it a little easier. It's still going to be kind of a pain in the butt, but it does make it a little easier. All right, so now, what can we do to both sides? get rid of the square root. How are we going to get rid of the square root? Square both sides. So square the entire thing. Okay. On the left, it just takes the square root off. On the right, don't forget your little shortcut. We're going to square -1. -1 squared is what? 1. What's up? We're going to square the square root of x. What's the square root of x squared? X. And then what do we do to get the middle term? Multiply them together and multiply that by what? 2. So -1 square root of x times 2 would be -2 square root of x. Okay? So really I don't need that plus sign. I just need to put minus. Alright. What happens to my x's? They cancel. They go bye-bye. Move my 1 over. -14 equals -2 square root of x. Scroll up a little. We're 2 steps away. What's my next step? Divide by -2. That will be 7 equals the square root of x. And finally, take the square of both sides. 49 equals x.
Can you explain the parenthesis, like the shortcut thing you did? That's all.
So, -1 plus the square root of x squared means -1 plus the square root of x times -1 plus the square root of x.
No,
Yes?
You said the
I know.
shortcut is to.
So, I'm going to do it the long way so you understand the shortcut. So, here's the long way. -1 times -1 is 1. -1 times square root of x is negative square root of x. Square root of x times -1 is negative square root of x. Square root of x times square root of x is x. This happens every single time. I get the same number twice in the middle. So rather than multiplying it all out, I just remember that, and okay, all I have to do is multiply these together and double them, because I'm going to get them twice every single time.
So square.
Square this, square that. Those go on the ends. Multiply them and double them in the middle.
But if you get confused,
If you get confused, you can always write it out and FOIL. Okay? The long way, hey, a lot of times this is the better way.
Get the short way.
Okay? All right? 13, just like number 12.
Just slow listen.
So I am going to move my square root of x over. One more again.
It's a negative square root of x.
It is, but when I move it, it's positive. Okay. What do I do now?
Square.
Square both sides. Square both sides. We get x minus 9 equals 1 minus 2 square root of x again plus x. We get the same exact thing on the right side. That's his. It's coming. Keep going.
It goes 1
All right.
minus.
The x's do what?
They're the same.
Oh, I gotta catch up.
That x and that x go away again. We subtract 1 from both sides. Negative 10 equals negative 2 square root of x. Five equals the square root of x, and then finally square both sides. You get 25 equals x. It means negative 1 plus square root of x times negative 1 plus square root of x.
And it's always going to equal that.
I wrote it out here. This particular one will always equal this, yes. Not all of them, but that particular one, yes. All right, 14, we got pretty much the same thing, except they threw an inequality at us. However, that actually makes it, this one's actually quicker and simpler. What do we do to both sides? Square both sides. Don't have to move anything on this one. Y plus 5 is greater than or equal to 9. Subtract 5. Y is greater than or equal to 4. Now, the inequalities are where you have to be careful, because remember, yes, it has to be greater than or equal to 3, but what can we not have under the radical? A negative. Okay, you cannot have a negative number under the radical because that makes it imaginary. Is there any numbers greater than or equal to 4 that would be a possibility for this problem? As long as we're putting numbers greater than 4, is there any way we're going to get a negative? No, so I don't have to worry about that. That's my answer. All right. On number 15, we got square root of 1 minus 7y is greater than 6. So we're going to square both sides. That'll get rid of the square root on the left side. 6 squared is 36. Subtract 1 from both sides. Negative 7y is greater than 35. And then divide by negative 7. Don't forget, since it's an inequality, when you divide by a negative number, you have to flip the inequality. And it will be y is less than negative 5. So, again, ask yourself, is there any number less than negative 5 that would make this square root negative? And there is not. So that is my final answer. Okay, y is less than negative 5. And what I mean by that is no matter what, obviously y is always going to be negative if it's less than negative 5. And if you plug in a negative for y, you're always going to get a positive because you're going to be saying negative times a negative is a positive. So there's no chance in the square root being of a negative number. You'll always be taking the square root of a positive number there. So 16, it says solve x over x minus 2 plus x plus 2 over x is greater than 2. All right, so this is the one, this is the little lengthy one because we're going to have intervals. You're going to make a little number line here just to show you the intervals. The intervals are your solutions as well as your, so as I was saying, sorry.
Teachers, when the bell rings, we'll be reporting to fourth block.
All right.
So when the bell rings, your students will be reporting to fourth block.
So we're going to find the answers, okay, as well as what can x not be. So for instance, right here, I know x cannot be 2 for this one, and it can't be 0 for there. So I know 2 and 0 matter, okay, they're called critical numbers. And then we're also going to solve this equation. So we're going to pretend like it's an equal sign, x over x minus 2 plus x plus 2 over x equals 2. And we're going to work this out. So I would, just like we've been doing, I'm going to multiply everything by the common denominator, which would be x and x minus 2, x minus 2, x minus 2. So once you multiply everything by the common denominator, you can cancel some things. So this x minus 2 cancels, and we'll get x squared. The x's cancel here, so we're saying x squared plus x plus 2 times x minus 2 equals, here I just distribute 2x to everything. So 2x times x is 2x squared, and 2x times negative 2 is negative 4x. And then we work this out. So distribute. These are actually conjugates, so you can just multiply the first and the last. So that's going to be x squared plus x squared minus 4 equals 2x squared minus 4x. The x squared and the x squared will make 2x squared minus 4 equals 2x squared minus 4x. And the 2x squareds cancel. When you subtract them over, they make 0. So they'll go bye-bye. Leaves us with negative 4 equals negative 4x. So x equals 1. So there's my other critical point. So again, you get your solutions, your answers, as well as what x cannot be. So here are my numbers that I'm going to put on my number line. So we got 0, 1, 2. You put them in the order they come. Okay? In the order, number order. I shouldn't say the order they come. You put them in number order. So I need to check something that's less than 0, something in between 0 and 1, something in between 1 and 2, and something greater than 2. And these are the 4 options for my answers. Okay? So of those 4, some of these are going to work and some of them are not. So let's plug in and see which one works and which one do not. So something less than 0, I'm going to plug in negative 1. So do a little separate problem right here. It's not a separate problem, it's just a little, I need some room here, all right? So negative 1, so I'm going to plug in negative 1. So x equals negative 1 here. So that would be negative 1 over negative 1 minus 2 plus negative 1 plus 2 over negative 1. And it needs to be not equal to 2, but was greater than 2. So greater than 2. Let's see if that's actually greater than 2. So this would be negative 1 over negative 3 plus 1 over negative 1. So basically we're doing 1/3 minus 1. Would that be greater than 2? The answer is no, it would not be. So x is greater, or x is less than 0 is not an answer. Okay, for our next one, between 0 and 1, I'm going to pick 1.5. So if x equals 1.5, we're going to do 1.5 over 1.5 minus 2 plus 1.5 plus 2 over 1.5. Is that going to be greater than 2? Well, let's see here. That would be 1.5 over negative 0.5 plus 3.5 over 1.5, which is, we're seeing if it's greater than 2. So let's see. Let's see if that, in fact, is greater than 2. So plug in my calculator. 1.5 divided by negative 0.5 plus 3.5 divided by 1.5. That is negative 2/3, which is not greater than 2. So let me make sure I plugged everything in correct. Because my answer says that should work. Oh, you know what I did? I picked, okay, that doesn't work. I picked the wrong number. So 1.5 would come here. So between 1 and 2 does not work, which is correct. Between 1 and 2 should not work. So that is a no. So what I messed up on is I should have tried, rather than 1.5, I should have tried 0.5 first. I need to try 0.5 because 0.5 is in between 0 and 1. So let's try this again. So if x equals 0.5, that's going to be 0.5 over 0.5 minus 2 plus 0.5 plus 2 over 0.5. Let's see if that's greater than 2. And again, I'm just sticking it in the calculator. All right, so we stick that in our calculator. I'm getting 4 2/3, which is greater than 2. So that is one of our answers. 0 is less than x, which is less than 1. And then finally, we try something bigger than 2, let's say 3. Let's say if x is 3 here. So x equals 3. Again, just plugging it in. 3 over 3 minus 2 plus 3 plus 2 over 0.5, or excuse me, over 3. Is that going to be greater than 2? So that would be 3 plus 5/3 is, I am positive that's going to be 4 2/3, which is greater than 2. Yes. So that one also works. So my final answers were 0 is less than x, which is less than 1, and x could have been greater than 2. Those are my answers. So that's the longest problem on the test, probably. It's a good one. All right. 17, 18, and 19. Thank goodness. These are all just calculator questions. So all you have to do is plug these in our calculator and figure out which model we need to use. So 17, you've got this big long table of problems. Let's see here. We got negative 2.5, negative 2, negative 1.5, negative 1, negative 0.5, 0, 0.5, 1, 1.5, and 2. And below that we have 12, 16, 13, 7, 8, 17, 35, 57, 105, and 185. All right, so first we're going to put this in our stat, but before that we need to kind of know what type of function we're dealing with. So you can know that from counting how many times it goes up and down. So for example, from 12 to 16, that went up. 16 to 13 went down. 13 to 7 went down. 7 to 8 went up. 8 to 17 went up. 17 to 35 went up. 35 to 57 went up. 57 to 105 went up. And 105 to 185 went up. So you count how many times the direction changed. So it changed 1 here. 1 here, okay? So it changed twice, which means it's a cubic, okay? That actually means it's going in 3 different directions. So it was going up, and then it went down, and then it went back up again, okay? Up, down, and then back up again, and it kept going up. So it's a cubic. So all I'm going to do is go to my calculator, and I'm going to type in to stat. So stat is this button right below delete, and I'm going to edit. If I have something there, clear them out. You scroll all the way up to the top, hit clear, and then scroll down. And I'm going to plug in these points. Negative 2.5, negative 2, negative 1.5, negative 1, negative 0.5, Zero, 0.5, 1, 1.5, 2, and then on the other side we had 12, 16, 13, 7, 8, 17, 35, 57, 105, and 185. All right, so now that you have them in your stat, we want to do the regression part on the calculator. So you hit Stat once again, scroll over to Calc to the right once, and then go down. And 4, 5, 6, and 7 is where you're looking. Okay, if it's linear, you'll use number 4. If it's quadratic, you'll use number 5. If it's cubic, you'll use number 6. And if it's a quartic, you use number 7. So this was a cubic, okay, which number 6. So I just hit 6, scroll down to calculate, and there is my answer. Okay, so I'm going to write down the answer. Y equals, A is 5.44, so I'll just say 5.45. I'll round to the nearest hundredth. X to the third plus 21.17 x squared plus 19.84x plus 13.97. That is number 17. Okay. For number 18, we do the same problem, same thing. I'm going to plug in different table this time. So scroll up, hit clear, go down. Scroll up, hit clear, go down. This time, my table goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the X. All right, all 1 through 10 on that one. And then 2 is going to be 4, 80, 49, 75, 124, 65, 32, 83, 41, and 12. Okay, and again, we're going to count and see how many times does the sign change to know which formula to use. So this one from 4 to 80 went up, 80 to 49 went down, 49 to 75 went up, 75 to 124 went up, 124 to 65 went down, 65 to 32 went down, 32 to 83 went up, 83 to 41 went down, and 41 to 12 went down. So as you can see, we had one change there, one change there, one change there, and one change there. So 1, 2, 3, 4. So this is definitely a quartic. It's actually changed 4 times, so it should be a quintic, but we will not have any that are above a 4 polynomial degree, okay? So this one is a quartic. So I do same process. I go back to my stat, edit. I'm going to go down to quartic, which is number 7. Go down to calculate, and there they are, okay? I'm going to give me a space to write up here the answer. So y equals negative 0.13 x to the 4th, would be there, 3.21 x to the 3rd, negative 29.85, so negative 29.85 x squared, 117.95 plus 117.95x, and last but not least, negative 82.42, so minus 82.42. There is your answer. Okay? All right. And our last one on 19, same type problem. We're going to edit our calculator list. And let's see here. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, all the way to 20. So 2, 4, 6, 8, 10. Whoa. Something's not right. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And then the L2 is your Y's. You got 12, 4, 5, 13, 9, 16, 19, 16 again, 24, and 43. All right. So, again, to know what we're doing, let's see here. 12 to 4 went down, and then 4 to 5 went up, up. 13 to 9 goes down, 9 to 16, excuse me, goes up. 16 to 19 goes up. 19 to 16 goes down. 16 to 24 goes up. 24 to 43 goes up. So we've got 1 right here change, 2 changes, 3 changes, 4 changes, 5 changes. So like I said, anything above 3 or more, you're going to be a quartic, okay? 1 change, it's a quadratic. No changes, it's linear. So no changes, it's linear. 1 change, it's quadratic. 2 changes, it is cubic. 3 changes or more, it's going to be a quartic. So we're going to do quartic. So stat, go over to calc, down to quart reg, which is number 7. Enter. Enter. And so my equation is going to be, again, some space to write it here because it's rather long, these quartics are. So we're going to have y equals 0.005 x to the 4th minus 0.22 x to the 3rd, and then we got plus 3.17 x squared, and then negative 17.34 x, and then last but not least plus 35.58. That is your polynomial equation for that table. Okay? And our last question, last but not least, it is also going to be a calculator problem. So, go to our stat, we're going to edit again. This one is in parts. So number 20 says Mexico's population is projected to grow throughout the first quarter century of the new millennium. And it gives you a table there. It gives you the years. And it gives you the recorded or projected population in millions. A says write a model that relates the population as a function of the number of years since 1980. So notice very carefully how they worded that. Write a model that relates the population as a function of the number of years since 1980. So when I go to plug in my years here, I'm actually not plugging in the years. The year says 1989, 1994, 2000, 2010, 2020, and 2025. But those are not the numbers you plug in. You plug in how many years since 1980 those numbers are. So, for instance, 1989, 1994, 2000, 2010, 2020, and 2025. So you have to ask yourself, 1989 is how many years since 1980? And it would be 9. So I plug in 9, not 1989, just 9. 1994 is 14 years since 1980. 2000 is 20 years since 1980. 2010 is 30 years since 1980. 2020 is 40 years since 1980, and 2025 is 45 years since 1980. All right, and then we plug in, for my Y, the recorded population in millions. So again, they don't want you to put 88 million, they want you to put just the number. So 88.1, I did too many 8s there, let's try that again, 88.1. The second one is 92.2. Third one is 109.2. The fourth one is 120.1. 136.1. And last but not least, 154.1. All right. And now notice the numbers continue to go up. So this is up, 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 up. So there is no change, which means this is going to be linear. Okay, so we're going to use linear regression. So for part A, let me clear all that off. I'll go to my stat, calc, number 4, go down to calculate, linreg. There is my answer to part A. I'm just going to put it right here. Part A, y equals 1.75x plus 70.6. Okay? If you put 70.58, that's okay too. Just know what you round will depend on what your part B and C is. Okay? Which is okay. That's fine. I'm going to be kind of lenient on the answers. So part B says use the model to predict the population of Mexico in year 2005. Well, 2005 is how many years since 1980? That would be 25 years. So I'm going to plug in 25 for X. And I work out this problem. So Y equals, if you put that in your calculator, you should get 114.35, and of course that is million because it's measured in millions. Okay? Part C, the last one, said use the model to predict what years Mexico's population will exceed 160. So this time the population is Y. So we're plugging in 160. Okay, 160 equals 1.75x plus 70.6. And we're solving it for x this time. Okay, so let me scroll that up a little bit. If I can, it won't let me. Well, oh well. Let me put it back here. I'll just write down here. Subtract 70.6 from both sides. $160 minus 70.6 is 89.4 equals 1.75x, and then divide by 1.75. So x will be 89.4 divided by 1.75, 51.08. Now, the question says use the model to predict what year Mexico's population will exceed 160 million. So understand your x is not the year, your x is the number of years since 1980. So we're going to add 1980 to that, okay? And so the population, the year it turns 160 would be 2031. And that would be your final answer for part C. So there's our review. I know it's long and drawn out, but we had a few things that happened in class today. I know you know it. Hope y'all get some use out of this and study hard, and we'll see you next time. And as always, stay above the line.